Welcome to the online video tutorial series of Computer Network subject. I am Nishan, Assistant Professor in IT/ICT Department of LJ Institute of Engineering and Technology. This is our second part of Unit 5 Data Linkage. So let's understand what we learned till now and what are the aim of today's video lecture. So in previous video, I briefly explained what is the role of data link layer in our OSI model and what are the services provided by our data link layer. And also I give the overview of error detection and correction techniques. So in this video, I will try to cover different error detection and correction techniques with the example, with the help of example. So basically, we are using three methods for error detection and correction: parity checking, checksum, and CRC. So let's understand with first one, parity checking. So parity checking is nothing. It is a very simple method that counts the parity of number of one bit in our set of B data items. In given data item of 101010, we have to count the number of ones. If our number of ones are odd, so our parity will be 1. So we have to set our parity bit as a 1. But if number of ones are even number, then our parity bit set as a 0. So basically our parity bit is divided into the two parts: single bit parity and two-dimensional parity. So let's understand this scenario with the help of first single bit parity method. It detects only single bit error. If any single bit error is occurring, it will have to find it. Suppose we have data item this, that is all about 0, 1, 1, 1, then 0, 0, 1, 1, 0, 1, 0, 1, 0, double 1. Now understand here how we are setting the parity bit at the sender side. Okay, so according to this given data, we have to count number of ones here in this data. Number of ones. Remember that we have to count number of ones bit here. So let's count 1, 2, 1, 2, 3, 4, 5, 6, and 7 and 8 and 9. Okay. So here total number of ones bit are here our which number, odd or even, that is our odd number. If you have confusion, then understand again, we have to count number of ones bit in given data item. So given data item is D here. Number of ones will be 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here in our data item, ones is coming for 9 times. So 9 is our odd number. That's why in the last we are setting parity bit is a 1, because in our given data item number of ones is occurring 9 times, and according to this rule, if our number of ones is coming 9 times or odd times, then our parity bit will be 1 number. If this number is occurring even times, one number of ones are coming even times, then our parity bit will be 0. But for this example, we have to conclude that number of ones are coming 9 times, that is odd number. That's why we are adding parity bit at the last as a 1. Now receiver side, what happened? The receiver side, if any one number of bit is changed, for example, here this second bit is changed from 1 to 0. So if the receiver is counting number of 1, so that will be changed, because right now we have number of ones 9 times and one bit will be changed from 1 to 0, then that is 8 times. So that is even number. So if the receiver is counting the parity bit for this given altered data, then it will be a even number. So parity bit will be 0. So that's why at the receiver side it will be considered as a error in a single bit. But more than one time, if the data bit will be changed, then we cannot handle by single bit parity. Now we are moving to the two-dimensional bit parity. So in this data, we can only send a single flow of data. But if we want to send the number of data, that will be a part in chunk. Then two-dimensional bit method will be used. So it is very common. It is used in the basis of row and column. So we have to set the data in row, number of column here. Here we can see that we have three rows and 5 columns of data. So in first row we can say here 10101. So in first row we are saying that total number of 1 is coming 3 times. So at the last column that is our parity bit column. So we are setting parity bit as a 1. This is for our row number 1. For row number 2 we have number of 1 how many times? 1, 2, 3, 4. So at the last our parity bit will be 0. For third row, we can see that 0, 1, 1, 1, 0. So number of 1 is coming how many times? 3 times. So in the last column, we are putting parity bit as a 1 because the number of 1 is coming 3 times, that is 1. So we are counting this parity as a row wise. But now we are putting that as a column wise also. So consider first column here. So for first column 1, 1, 0. So number of 1 is coming for how many times here? 3 times. So we are putting as a 1 as a 0 as a particular time. Then we are also putting 1 in the second column 1, 1, that is 0. Then for third 1, 1, 1, that is odd number. Then parity bit is our 1 here. So here when we are seeing that in first column and second column number of 1 is coming twice and it is even number, then that will be a case when our parity bit will be 0. Otherwise it will be a 1. So column wise and row wise we have to check the parity bit. But at the particular receiver side, if any bits will be checked, then we are finding the errors. Now this is also another example how we are checking the parity bit. So this is our data item. For that I am calculating 1010 and 011. So we are calculating that, and 1, 2, 3, 4 and 5. 5 times 1 will be come. For that we are putting parity bit as a 1 because 5 is a odd number. The same way if we are counting for the second, third and fourth row, we are getting the parity bit 1, 0 and 1. So this is when we are calculating like this. This number is considered as a row bit number. But if I calculating like this, it is a column wise. So if I am calculating this 1, 1, 0, 1. So for first row 1 number, second row 1 number, third row 0 and fourth row 1 number. Then total 3 times I am getting 1. Then that is odd number. So my parity bit will be 1. So same way for second column, third column, 4, 5, 6 and for 8 column we are finding this. So here we are getting row parity bits and column parity bits. When we are sending the data from source to destination, what happened here? First, what the data is coming, that is data, and then we are append our parity bit here. So when we are sending the data, this is the data which we are sending to the receiver. Okay, that data will contains first 8 bit as a original data, and the last bit will be our parity bit. So this is, I think all of you are now clear about the parity checking method. Now we are moving to the second method of error detection, that is a checksum method. So let's understand checksum method. So for checksum method, there are two parts, sender and receiver. So let's understand both the one by one. So at the sender side, what happens? At the sender side, whole data which we want to send from source to destination, we are divided into the k segments, into the m bits. So first we are decided how many bits we want to send in one segment. So that segment is k. In that particular one segment, we have to decide number of bits. That is our first one. Then we have to add all that m segments using ones complement arithmetic operation. So simply we are performing our arithmetic ones complement operation. In the third step, we are getting the final sum of this segment, and then we are performing the complement of that particular sum, and that complement is known as a checksum method. That is our method. So here checksum will use here as a vital role. Checksum will be key for our checksum method for error detection, because the same checksum what we are generated at the center side is used for error detection at the receiver side. Okay, so let's understand at the receiver one. So what happened at the receiver side? So at the receiver side, all the segments which are sent by the sender is received by the receiver, and first it will add all that particular segments using one's complement arithmetic operation that is already used by our sender. Then again the sum is complemented. So final sum what we are getting at the receiver side, we are complemented. So our addition of our complement is 0 at the receiver side. Then we understand that all the data items which are sent by the sender of a segment, that is correct. Otherwise we are rejecting that as a error detection techniques. So how exactly the particular checksum will be used, that we understand with the help of one example. Understand, this is our data item 0 1 1 0 1 1 0 0 1 1 1 0 1 0 1 0 1 1, then 0 1 0 1 1 0 1 0, and the fourth one will be 1 1 0 1 0 1 0 1. Now what the operation what we performing at the center side? At the center side you can see here k is equal to 4, because our total number of segments are 4. 1 2 3 4. Each and every segment having 8 number of bits. That's why I'm saying we are writing m is equal to 8. Now the task of arithmetic ones complement. So first we have to add first two segments, first and second segment. To understand this, first and second segment is given, and we are starting our arithmetic operation. 1 1 0 carry is 1 here, carry is 1. Okay, 1 1 0 and carry is 1 again. Carry 1 is carry forward from our first point, so answer is 1 and carry is 1. So our third point will be 1. Then 0 1 1 1 0 1 1 1 0 and carry is 1. So this number is 1, and also 1 1 0. This is the last term 1 1 0, but carry is 1. So I am adding here 1 again. So at the last 1 1 0 and carry is 1 generated. That's why we are putting this time 1 plus 1. So after adding that we are getting 0 1 0 1 1 1 1. So this is the answer of first two bits addition. Now we will add the third term n is equal to 3 to our addition of this. So I am putting 0 1 0 1 1 0 and 1 0. That is our third term. Now we are doing the same task of addition using one's complement. Then we are getting this number. At the last we are getting this, and we will add the fourth number. Fourth m is equal to 4. That is from given data item, and we are adding. Then we are getting this particular answer. That is our sum of at the sender side data. But for error detection technique, we require checksum number. So how can we get that checksum? So for that, it is very simple. The sum of all the data bits what we are getting here in this step, we have to complement. So complement will be 1 to 0 and 0 to 1. So we are getting this complement here at the sender side. Now what the process performed at the receiver side? So for that we see the particular example at the left, your right hand side. So what happened here? The same task will be performed. What the task will be performed by the sender, the same task will be performed by the receiver. So it take the first two data, then do the addition, then the answer will be added with the third, then the answer will be added with the fourth, and it will get the final answer, final sum. Now what happened here? The final sum will be added with this complement, that is our checksum. So that particular in the first second third line you can see here 1001111. That is my addition of all four terms at the receiver side. Then I am adding the checksum which will be getted at the sender side here. Then the answer will be sum here. So at the receiver side is my answer of my checksum and addition of the all the data item of the receiver data. Now sum will be 111111. All data item, all the bits is 1. Then we have to provide the complement here. Then we have to perform our complement. Complement number is here 0. So according to our condition, if at the receiver side all these complement number will be 0, then we can say that all our data item from source to destination is successfully received. Not a single data is checked. So let's understand that I already write in this type. If the result is 0, the receiver is received the data and that is accepted, otherwise it is rejected. So in this checksum example, at the receiver side we can see that at the complement all the data items are 0, and we can say that our data is successfully received by the receiver. No other data is altered in this particular transmission. So this is the basic of checksum. So checksum is very simple method. We are performing once arithmetic operation, and last we are finding the checksum using the complement method. At the receiver side we are added that particular checksum, and if we are getting the complement of that as a 0, then that data is successfully received, otherwise it is a rejected. Now we will understand in detail what is the CRC in the next video lecture. Thank you for watching this video.